Thank you. And hello, friends. I see a lot of familiar faces out here. So, as some of you know, for the last 22 years, I've been providing holistic health care at what I call the Center for Sustainable Medicine. And a lot of my focus has been on nutrient-dense diets and on grass-fed foods. And for the last 9 years, I've been working on this book, The Ecology of Care. The subtitle, the sort of impossibly long subtitle, is Medicine, Agriculture, Money, and the Quiet Power of Human and Microbial Communities. And as I was writing the book, I started to understand more deeply the connection between our own interior health in our interior landscape, in particular the microbiome, and public health as a larger question, not just for us, but for all other species in the outer landscape, based on what I call the microbiome of the landscape. So I went from being an acupuncturist to monitoring soils and teaching about soil monitoring for change over time in carbon and water infiltration and other indicators of soil health. And a lot of my patients were concerned that I was giving up my practice, but I told them, don't worry, I'm still sticking long, slender metal objects into complex living systems. So, you know, and you're gonna be healthier because of it. So. And over the past 2 years, I realized that the thing that I could do that would probably make the biggest difference in all of this was to start developing learning resources for schools. And so I've been working with schools in Vermont and New Hampshire, and next week in Chicago, and with a bunch of teachers in California. And Jane Heinz-Frey, who's here from the Museum Institute for Teaching Science, has been incredibly helpful in helping me to think about aligning it with the next generation science standards, which are beautifully designed to teach whole systems landscape function. I mean, I couldn't have asked for a better set of standards the more I look over them. So, this is a quote from Stephen Buhner. Bacteria are not germs, but the germinators and fabric of all life on Earth. In declaring war on them, we declared war on the underlying living structure of the planet, on all life forms we can see, on ourselves. And in my book, this is what I call the shift from a fertile model of care that we used to have for people and land to a sterile model of care where we kill off whatever we don't want. And what we're now seeing both in regenerative agriculture and in holistic health is a shift back to fertile models of care where we recognize the incredible amount of work that microorganisms do. So this is what greeted me at the San Jose airport the last couple of times I went to California. It says, welcome to San Jose. Sanitize here, complimentary hand sanitizer, free hand sanitizer. San Jose welcomes you. I just love this because it's such a great example of what's become of our society in terms of how we think about microorganisms, that they are just plain old bad. In actuality, there are only 200 species of bacteria that are responsible for illness, and there are, millions, probably billions of other ones that basically create health. So they do this work that we depend on, both in our guts and in the land and everywhere else in the ocean. Who can say a few things that they know that our personal microbiome does in terms of our health? Helps us process nutrients, yeah? What else? Digest food. How about, what's that? Yes, vitamin B12. Yep, maintains our immune system. Somebody over there is saying something? Oh, okay. Yeah? Makes cheese, yes, it makes cheese when we do it on the counter, and probably makes some cheese in our guts too. um, regulates our mood, yeah. How much of our serotonin is created in the gut? Yeah, somewhere between 90 and 100%, depending on where you read. Most of our brain chemicals are produced by microorganisms. And if you take the microorganisms from an anxious mouse and put it into a calm mouse, what happens to the calm mouse? It becomes anxious. And if you go the other way around, it's the other way around, right? You can take the microbiome of a calm mouse and put it into an anxious mouse and calm them down. And do you know what turns on the process of brain development in the human? Microorganisms, yeah. So we really wouldn't be human without this inner landscape of microorganisms. So in the soil also, these microorganisms do a lot of work that's really unrecognized, and we're just starting to understand it. I like to think of soil as a carbon-rich sponge that soaks up water, but more importantly, as an intelligent carbon-rich sponge. And what does that mean that it's intelligent? Well, there's something called mycorrhizal fungi, if you say it the Australian way, that they extend plants' root systems, both for water and also to get nutrients. And they are actively traveling through the soil to seek out nutrients and to exclude toxins. So in a single cubic meter of soil, you can have 25,000 kilometers of these fungal hyphae doing a lot of work for us. The only way, this is just a plug for Ridgeton, the only way to really get the full benefit of that intelligent filter for nutrients, where it's excluding the stuff we don't want and bringing in the stuff we want, and in our current food system, the only way to really get that is either through wild foods or through grass-fed animal products. So let's see. So I have a little demonstration I want to do. I would have liked to have done it up here, but we don't have a camera right on it. But can I get 2 volunteers who are comfortable to kind of get down on the floor here? Especially if there's 2 people. Don't worry, I won't make fun of you in any way. Some of you saw this, my student Emmeline Conkey did a little videotape of this, which you can see on YouTube. It's called Emmeline's Water. That's good. The 2 of you are perfect people to do this. Okay. That one's a little used. But okay, so this is how you can teach about the purpose of soil aggregation and soil microbial life to anyone at a dinner party. Okay, so on this plate, we're putting a cupful of flour. And on this plate, we are going to put a few slices of lovely industrial bread, but it should be done with sourdough bread. But I didn't want to harm any microbes in this demonstration. Okay, so then we take a paper cup, a ecologically harvested toothpick, not from the rainforest, poke a few holes into it, okay, so, all right. So Jane, why don't you just put that down on the ground right up front. Okay, and you're just going to hold that over there and rain on top of that through the cup. Okay, so how many people here have ever, well, I'm just going to have Jane describe what she's seeing. Most people here have probably poured water onto flour when you're making bread. How many people have ever done that? Yeah. You kind of know what's going to happen here. So Jane, what are you seeing as you do that? Oh, careful, it's going to spill right out the edge because of what we're describing. Okay, that's good. That's plenty. That's plenty. Okay. Stop. Okay. Hang on. Hang on, we're having a flood. Okay. Sit here and bring the other one over quick. Okay, get us some carbon-rich soil. Here, Jane, hold that. Okay. Okay, what happens if you pour water onto bread? And what have we done to flour if it was normal bread? What would we have done to the flour? What's the only thing we really need to do in order to turn it into bread? Is to add biological activity in the form of yeast. Okay, so that biological activity takes those little particles, which if this were soil, the particles are simply broken down rock material, sand, silt, and clay. The microbiology that is fed by the roots of the plants takes those particles of sand, silt, and clay and gloms them together and creates a structure that is filled with pores. And that is more like bread. So if you pour water onto a landscape that is more like a unaggregated soil, more like the flour that's just sand, silt, and clay, then you get erosion, you get runoff, and it doesn't actually soak in, right? When you've made bread at home and you first pour that water on before you add the yeast. Okay, so if you lived in a landscape like Vermont, where you get many, many, many inches of rain every year and you're prone to flooding, which soil would you rather have near you? The aggregated bready one, or the other one, or the flour? The bread, okay. If you lived in a landscape that was only got a few inches of rain every year and you needed to grow food, which would you rather have? The bread. If you lived in a landscape like Oklahoma where the winds blow really hard, which would you rather have? The bread. There's what happens if you don't have the bread. If you lived in a place that was prone to earthquakes and your infrastructure was built on soil, which would you rather have? The bread. If you lived in a landscape where farms were all around the lakes and people were using chemicals in their farming, the bread also acts as a filter. If you were trying to slow down ocean rise, sea level rise, which would you rather have? That spongy bread or just little particles? The bread. So the point is that no matter what your purpose is, this soil carbon sponge is really important for us to be rebuilding on the land. So how do we do that? A lot of people want to know, what are the practices that I can do to make this work? Well, at the Soil Carbon Coalition, we like to talk, instead of practices, we like to think about principles. And Ray Archuleta, who's a phenomenal speaker from the NRCS, which used to be the Soil Conservation Service and is now the Natural Resources Conservation Service. He's come up with these principles. I've tweaked them just a little bit to kind of flesh them out a little. But one is to keep the soil covered year-round. So whether that's with hay or straw or clover or grass or a pasture. The second one is to keep living roots in the ground year-round, because that's what feeds the microbiology of the soil to create that sponge. The third one is to use plant diversity above ground to increase the microbiological diversity below ground. This one I love because this is so true with our own microbiome also, that the more diverse of a diet we eat, the more diverse we are feeding the microbiome of our gut. So, and then minimize physical, chemical, and biological stresses. Whoops, this one's good. It's missing a little bullet there. But so physical stresses, such as like turning the land over and exposing it to heat. Chemical stresses, we know about that in agriculture. Biological stresses could be all kinds of issues with having the wrong biology that you are trying to put in the land. So, adding things that the soil doesn't want there. Integrating a diversity of animals, so especially grazing animals that can help move those nutrients uphill while also composting them. And then getting to know the context of the land is really important. And that's where this is principles over practices, that it's really different what you might do in a particular landscape or what's going to work well, but the principles are the same. So this is Kansas in June. How many of those soil health principles do you think are happening there? Not a whole lot. So there's been a lot of tillage. There's no plant cover on most of the ground. There's a lot of chemicals being used. There's very little animal impact. And this is typical of our farming system. And the same person who came up with those principles, Ray Archuleta, said this soil is naked, hungry, thirsty, and running a fever. This is a really cool thing that the NRCS brings around from one farm to another, showing how soil that has been treated with all of those soil health principles, you can see that underneath the water is going down through the soil, but it's not running off, and what's coming through is clean. And then you go all the way over to this one that has had no cover, has been tilled a lot, and you have a lot of dirty water coming off of the soil and nothing infiltrating down into the soil. So very similar to what we showed with the flour and the bread. Just in a particular landscape, so Peter Donovan and I traveled up to Saskatchewan just right after these floods in 2014, and this is most of the wheat and canola farmers there had lost their crops, and all the seeds were just rotting in the ground. But the people who are practicing holistically managed grazing, they had beautiful pastures alongside the rivers, and the rain just went down into the ground and grew more food for them rather than becoming a big mucky mess. One of the other benefits of this is that you can build soil carbon, which is the life of the soil, by doing these kind of principles. And so Peter Donovan and I have been going around and putting in baseline plots at over 300 innovative farms and ranches all around North America. And we're starting to find out who are the successful working class people who are really doing things in the land. And this is Ralph and Linda Corcoran. They are gaining 13 tons of carbon on each hectare each year, which is 1 square mile of that land is building carbon that's equivalent to 800 Canadian people's annual CO2 emissions. So a big piece of our work is about recognizing the work of the working class, so that whether that's people or whether it's what I call the working class of our interior landscapes or our exterior landscape, who's doing that quiet, unrecognized work that provides us with the goods and services that we depend on every day. Where's the carbon in this picture? In the grass? In the soil? In the cow? Yeah. One more place. In the air, yeah. So we tend to think of carbon as like something on the periodic table, but carbon is life. And when we get the carbon cycle working perfectly in a landscape, we're just building more and more life through the process of photosynthesis and microbial action. So we've talked a little bit about the intelligence of the gut and the intelligence of soil, but how do you measure the intelligence of your land? Well, that's what we're developing ways for people to inexpensively measure the change over time in soil carbon and change over time in water infiltration, change over time in the biodiversity of the ground cover, change over time in how much ground is covered, and lots of other indicators of soil health, change over time in the rate of photosynthesis on a piece of land. And we're mapping it all on our map on the Soil Carbon Coalition. That's actually in the process of being updated so that people can do it directly from an app on their phone. Don't have to go through and input all that data. It'll go right onto the map. And in order to train people to do that, we're doing something called the Land Listeners Project, which there's a sheet in the back if you're interested in being trained to gather this information, get to know the real landowners with real projects and real data, which is very different than the kind of computer modeling way that we tend to look at landscape function and climate change and water cycling. We're seeing what's actually working in real time. And as I said, Peter Donovan in 2011 started something called the Soil Carbon Challenge, where we now have over 300 plots, and we're starting to get data back as we go back and remonitor those. And in order to do that, he sold his belongings and bought an old school bus that we travel around in, which is a pretty nice way to live. So this is my book is for sale at the back, The Ecology of Care. My email, just to make things simple, is ecologyofcare@gmail. And 2 websites, sustainablemedicine.org is my original website, and soilcarboncoalition.org is for the Soil Carbon Coalition, obviously. And the books for sale they're actually being sold separately from the other ones, just because I guess it was the bookstore, who knows what. But anyway, if you want a book, and just come see me, and I'll try to be there during the break. Thank you.